Hello, my name is Sai Karthik. I'll demonstrate our crypto volatility detection system, a production-ready AI service that predicts Bitcoin volatility spikes in real time with just 45 milliseconds latency. Starting all services is simple. One command launches six services. By running the Docker command, I would be launching all the services. Now we can see that all our services are up and running. The Docker Compose configuration defines all services with health checks and proper dependencies. Services start automatically in the correct order. Now I can check the health of the service by hitting the endpoint of our Fast API, and we can see that our Fast API services is up and running. The next part of my demo involves explaining you about the prediction service. Prediction is done either ad hocly through the Fast API or real time through the Kafka streaming service. To do the prediction ad hocly through the Fast API, I would be making a post request to the prediction endpoint. And here I would be making a post request, and now we have got a result with the prediction and the probability. The next step is showing you how we can do the prediction real time through the Kafka service. For this, the first step is ingesting the data from the Coinbase WebSocket, and I would be running the ws underscore ingest file, and we can see that the data from the WebSocket is being flown in. The next is to run the featureizer file. The featureizer basically takes the raw data from the WebSocket and then builds the features, and these features are then sent to the ML model for which does the prediction. We can see that features are being built to the live stream, and the final step is to show you how the live streaming of the prediction happens. This is done by subscribing to the topic text.prediction topic. And now we can see that the predictions are happening real time for each tick of data that's flowing into our system. I would hand over the demo to Tina. Thank you.
Hi, I'm Tina and I'll walk through the resilience features built into our real-time platform. So our goal was to keep production systems up and make sure that they survive failures automatically and any network hiccups or Kafka restarts. For our Kafka producer resilience, we have the ingestion script configured such that the retry count is increased from 3 to 10 attempts, and we've also added exponential backoff from 1 to 10 seconds and enabled socket keep alive to maintain the long-lived connections. If Kafka ever goes down, the producer won't crash or drop data, and messages will simply buffer and retry automatically when the broker comes back up online. And this will give us reliable and zero data loss ingestion. Now, in the prediction consumer script, we have a similar setup. The consumer will automatically reconnect on transport errors, use exponential backoff for retries, and also commit offsets gracefully on shutdown. So even if the network blips or the broker restarts for whatever reason, the customer should pick up exactly where it left off, and no duplicates and no data gaps should occur. We also have a reconnection logic here in the ingestion script. So the ingestion is also built to self-heal, and we use exponential backoff here, starting at 5 seconds and doubling to a maximum of 60 seconds. That prevents us from hammering the Coinbase API while still reconnecting automatically whenever the feed drops. We also have heartbeat monitoring, so any dead connections are detected quickly and gracefully fail. So, putting all this together, the application gives us 24/7 reliability, and network failure, service restarts, temporary outages, everything recovers on its own with no manual intervention and no data loss. And in our logs, you can actually see the automatic reconnection attempts happening in real time. So, in production, this means that there is zero downtime, even when there are underlying infrastructure issues. Now, Nicole will demonstrate the model rollback features.
Hi, I'm Nicole. I will demonstrate our model rollback feature. This will ensure a safety mechanism for production ML system. So first, we're gonna check the current model. Currently using our SGBoost. Let me show you a quick switch to a baseline model if any issue arise. So in our compose YAML, you can see we have a few lines of comment. This variable model variant, when set to baseline, switch to our backup model. Just uncomment this line and restart. When environmental variable change, under 2 minutes, rollback. And the baseline model we use is a simple stats model instead of machine learning. So it's less accurate, but very reliable. It always works. And in emergency, the user will stop the service, set the model variant to baseline, and restart. It takes under 2 minutes with zero downtime. And what they're gonna do is do these commands, and the service will restart using the baseline model. API continues just serving the prediction. And you can see on the right-hand side, we also have a model rollback feature guide for the user. It includes things such as when to use it, and also testing steps, recovering procedures, and anyone on the team can execute a rollback very quickly. So our system rolling back forward is super easy. Just remove the model variant and restart. This rollback feature ensures we can maintain the service even when the ML model has issues. So that concludes our demo. We've shown the system startup, real-time predictions, automatic failure recovery, and model rollback. So thank you for your time.